Okay, so solving systems by substitution is another way that we can solve systems. Now, not only is it important that we understand it's another way that we can solve systems, it's also important that we understand, like, we need it. We can't just decide, you know what, I really don't like this whole substitution thing, so I think I'm going to go ahead and start solving everything by graphing from this point forward. Because what happens if we say, oh, this marker is terrible. What happens if we say y equals 17/25 x plus 147 and y equals 2/9 x minus 58. And we want to solve that system by graphing. I mean, could we graph those two things?
Yeah. Numbers two. Yeah.
I mean, if we're just talking about the concept of graphing them, yes. But William, why did you instantly go to the numbers are too big?
Because the graphs usually only go up to 10.
I mean, who's going to make a graph that goes to 147? Ugh. And then you're counting up 17 over 25 from that. None of that sounds enjoyable. Okay, what happens if we graph two lines and they don't intersect at a nice, neat point?
You have to guesstimate.
And how does Mrs. McKinney feel about guesstimating? I hate it. Okay, so we need another plan. And that's where substitution is going to come into play. Okay, now, I don't want to make us have to do these types of problems and force substitution. So for right now, we're just going to pretend that the two problems I write up here we can't do by graphing so that I don't have to give you really large numbers. Sound good? Okay, so let's say we have y equals 6x plus 12 and y equals 4x minus 10. Is this a system?
Yes.
How do we know it's a system?
No repeating x.
What makes something a system?
Y equals.
No. That makes it like we have it set up as a function, but what did we say made something a system of equations?
More than one.
Say it again, Mason.
More than one equation.
So we have two equations and there was something else we had to have. Two equations and two
variables.
Two variables. So we have two equations, we have two variables, so we know that this is a system. Okay, we're going to pretend that we couldn't do this by graphing. So we're going to go the route of substitution. So substitution says we want to find a place that tells us what one variable is equal to. To do that, we want to look for an x equals or a y equals. So is there anywhere up here that we can find an x equals or a y equals?
Yeah.
Yeah, we actually have two of them, right? So we're just going to pick one. Anybody have a preference as to which one they want to pick?
No.
First one.
The top one? Okay, so we're going to circle that x equals or y equals. So in our first step, we are going to circle an x equals or a y equals. Now, do you have to circle to actually be able to do substitution? No. I'm going to try and give you some visual cues because as the problems get bigger, you don't want to make mistakes. You don't want to miss anything. So I'm just going to try and give you some visual cues here. Okay, then, what is y equal to in this situation?
6x plus 12.
6x plus 12. So in our second step, we are going to underline what it equals. Now, while yes, I'm giving you these as visual cues, it's more important that we understand what this statement is. Okay, we said that an equal sign tells us that two things hold the same value. So if Claire has Y amount of money, and I have 6x plus 12 amount of money, who has more money?
It's the same.
It's the same. How do we know it's the same?
Is y equals.
Because there's an equal sign,
Yes.
right? It's telling us that they hold the same value. That then allows us to say any place that I see a y, I can replace it with a new value. So anytime a recipe calls for butter, I can replace it with margarine. So anytime a function uses a y, I can get rid of the y, and I can replace it with its new value. So what does y now equal? 6x plus 12. Okay, so for my third step,
Big flash.
I'm going to cross out the letter I circled. And I'm going to replace it with the underlined stuff. I mean, that's really fancy words there, right?
Yeah.
Right, I'm replacing it with the underlined expression. Because y and 6x plus 12 are the same thing. Right, just like any place that I see $10, I could also give someone 2 5s. So any place I see a y, I could also give 6x plus 12. Then once we do that, we now have a new equation. So now we see an equation that says 6x plus 12 equals 4x minus 10. And hopefully we all look at that and think something. What should we maybe be thinking?
We've already done this.
Yeah, we know how to do this. Would we all agree we know how to solve this equation?
Yes.
And there's variables on opposite sides, so how are we going to get them together? Subtract the 4x, they're on opposite sides, so we're going to use the opposite sign. If you're like, holy crap, Mrs. McKinney, I don't know what you're talking about, we have some work to do before final exams. Okay, then what are we going to do next? Subtract the 12. And then what?
Negative 1. Or 22. Oh, it's negative 10. Shoot.
No, he had thought this was a
I
1.
thought that was positive 10, so I did everything wrong.
Oh. Yeah. Okay, so we get x equals negative 11. Any questions on where that negative 11 came from? I solved an equation, I'm done. Check. I'm done?
No.
No.
Why not?
You have to graph.
Nope, I don't have to graph. Why? Yeah, but why?
Make sure it works.
No?
We haven't found y yet.
And why is that important, Mitch?
So we find y.
Why? Are we solving for y?
Yes?
Yes.
Because we don't know why is.
I mean, we do need to know what y is, but why?
Because that's y equals that equation, so we need to know.
So that x equals 11 isn't negative 11 isn't important?
It is.
Yeah, it's what x is. That's what x is.
Because it
That
can
is true, this is what x is. So why do we need to find y?
to see if it's a true statement.
No?
Substitution.
I mean, it is substitution. What is the answer to a system?
A point.
X and y.
X and y.
Oh,
Right?
I remember
This,
last year.
the solution to a system is both x and y that make both equations true. So we don't have an answer until we found both variables. Right? That's the whole point of a system, is that we want to know what x and y are. So we're not done because we don't have both variables. Now, most of you are then making the correct assumption. Well, I can just plug this in back up here, right, and do another substitution, and that's exactly what we'll
It's a big
do.
number.
Okay, so we can just substitute it back in. My suggestion is that it's usually, it's not a guarantee, right? These are sort of like guidelines. Okay, it's usually easiest to substitute in where you underline. The key is to make sure you are substituting for the correct variable. So we solve for x, So what is negative 11 going in for?
X.
X, right? So we're bringing this up here and we're plugging it in for X. So now instead of saying y equals 6x plus 12, now we're going to say, oh dear, y equals 6 times negative 11
Plus 12.
plus 12.
Equals negative 54.
So negative 66 plus 12, y equals negative 54.
Yes.
Yes.
Do we have x and y?
Yes.
Yes, so if we say x equals negative 11 and y equals negative 54, we have the correct answer. We're fine. Multiple choice though, the majority of the time our answer is going to be represented as an ordered pair, like it was when we were solving by graphing. Just for the fact of it's less writing. I know how you all like to write as least amount as possible. How would we write this as an ordered pair? Well, do you know?
Oh yeah, it would be negative 11, negative 54.
Negative 11, negative 54. Did you have another statement you wanted to make?
I have
William?
another question.
Yeah.
Do we ever have to graph this? Like, because we have the point and then we have the slope, which is 6. So.
I mean, yeah, so I mean, we could go in and we could do graphs, but that would just be like if we chose to solve it by graphing.
Okay.
And here is the reality. I think this is the statement we've all sort of been misled on for so many years of our life. I mean, no one's going to come up to you and say, hey, Will, solve this system of equations and I'll give you $500, right? A system of equations on its own is kind of pointless, right? It's how do we solve something when we have two unknowns? We might need to use a system to help us solve it. So for example, I was painting my daughter's room. Okay, my daughter's room has a bunch of different squares on the back wall. Okay, and I wanted them to fit lengthwise and widthwise without having an odd space at the top and bottom. So I needed to consider length and width of the wall. So I had two variables I had to consider. I mean, could I just start guessing and checking?
Yes.
Yes. How long may that have taken me?
Forever.
I mean, for quite a while. Or I could just write a system of equations with the constraints that I had in both ways and solve it and figure out what those numbers were. No one came up to me and said, here you go, here's a system. That's chapter 7 in Mrs. McKinney's class, right? It's that, oh, I knew I had two unknowns and being able to solve for them required this. So, I mean, do we need to graph it? No. Could we graph it? Yeah. Okay. Questions on this example? I want to look at one more with substitution. As they start to get more complex than this, I have to look. I can't just make them all up. So here we go. How about x equals 9y minus 10 and 6x plus y equals negative 5. How do we feel about solving this by graphing?
No.
Does this look like something we would want to solve by graphing?
No.
Why not?
Because
Because
x is by itself.
Yeah.
Right, y isn't by itself, x is by itself. We're going to have to do a lot of solving for y to even get to graphing. I don't know about you all, but graphing usually isn't my favorite. As easy as it is, I think most of us started to get to the point of it's really annoying to count all those little dots, right? Of up and over, up and over, up and over. It's just kind of tedious. Okay, so let's go the route then of substitution. So our first step is we're looking for an x equals or a y equals. Do we see one up here?
Yes.
Where?
X equals.
X equals. Do we see a y equals down here?
Yeah.
Kind of. Can I circle that y?
No.
Not really. Why?
Because
It's not alone, right? Now, do we know some math to be able to get that y alone? Sure. So if you wanted to do the math to get it alone, you could, but I mean, right? A lazy mathematician is a good mathematician. That's our rule. So then we're going to underline what x equals. So what does x now equal?
9y minus
9y minus 10. So that says any place that I now see x, it is the exact same value of 9y minus 10. So I'm going to go to the other equation. Okay, so I'm going to go here. And wherever I see x, I'm going to cross it out. So I'm going to take this x and I'm going to get rid of it. Can I cross out that 6?
No.
No. Right? Because I don't know what 6x equals. I only know what 9y minus 10 equals. So the only thing that I can get rid of is the x. Okay, what's going in place of the x? 9y minus 10. So right here above this x, right, I'm putting in 9y minus 10. I mean, I can't just write 9y minus 10.
Parentheses.
Why parentheses, Mason?
Because normally it'd be 6 times x.
Right, so what operation was happening in between the 6 and the x? Multiplication. How do we represent multiplication between one number and then a set? Parentheses. So this is going to become 6 times 9y minus 10. And then I'm just going to keep writing. Plus y equals -5. I never said these problems would be short. They take up some amount of paper. And hopefully then when we look at this, what does our brain say?
Distribute.
We know how to do this, correct? So we can distribute. What are we going to do after we distribute? Combine like terms. Are they on the same side or opposite sides?
Same.
So same side, same sign.
Yep.
Add 60.
Add 60, and hopefully at this point we're like, okay, I can do this. 55y equals 55.
Yes.
Are we done?
No.
Why not?
We need x.
Why do we need to find x?
Because that's the answer to a system.
A system has an answer of what?
X and y.
X and y, or a and b, or c and f, right? Whatever two variables. So we need to take this y and we need to plug it back in. Where would we like to plug it back in?
The top equation.
Right? That top one, again, you can plug it in down here, but this one's just going to be way more complicated to go to the 6x plus y, and then you have to do more solving. Plug it in where you underlined. It's a lot easier. Okay, so now we'll say x equals 9 times 1 minus 10. 9 times 1 is
9.
9. 9 minus 10 is
One.
-1.
Negative 1, 1.
Okay, so writing down on your final answer, x equals -1 and y equals 1 is fine. Or if we wanted to find this as an ordered pair, it would say
-1.
-1, 1. How do we feel about these?